All right. Hello. Today I am discussing the independent sample t-test, and this is where we are comparing. So last time we just did a sample t-test. This time we're actually going to be comparing, and in this case we're going to compare two campuses and discussing and trying to determine if the mean for each of those campuses is significantly different or not. So it's very, very similar to what we did, just the sample t-test. The only difference this time is we're really comparing the two campuses together. And then, of course, we have the total population once again. So to start, but you always got to start with your end in mind. What is your question? What are we trying to find out? So once again, I just was trying to determine, I did keep the campuses the same. I just chose fourth grade because I'm fourth grade reading, just so I could kind of stay aligned. So I chose to determine if there's a huge difference between the 2019 raw score mean on the fourth grade reading test for all students for Campus 101 compared to 107. So here are the two numbers. But to be able to find all that, first I had to take the lump sum set of data and then narrow it down to exactly what I needed. Like I didn't need the names. There was a lot of information I didn't need. So I had to simply delete those columns. And then to get the campuses, because I only needed two campuses, which I did split them at first, but then I was kind of having trouble going from different sheets to when I started inputting data on the different tool pack and just the charts. So I did end up putting Campus 101 on top, and then I put the 107 on bottom. So I would have them both on the same spreadsheet. But to start, you first have to, of course, find what was the total mean and the standard deviation for the whole population. And just be careful when you're selecting this p-value chart LTA because like previously, I just did African American, so I chose African American. This time I'm looking at the total group, and of course I'm looking at reading this time. So this is where I found the mean and standard deviation for the total population. So you will find those numbers here. And then as I moved on, I first found the average or the mean for Campus 101, which was my first campus. You'll see right here, 101, and you will see I actually did this kind of on the bottom. I found the average, and then I found the standard deviation for both of these items. So I would have them to put in my table because I will need them now as well as later on in the different types of tests for running and charts and such. So I did that for both campuses. And then just by looking, once again, we talk about how numbers can be deceiving. The standard deviations are really close, but there's a pretty big gap here. It's looks about like 3-point difference. So really, I'm just trying to see, is that truly a big difference or is that not a big difference? And that is the whole reason why I want to run these tests, because we all know just by looking at numbers, you know, they can trick you. They can make you think, oh yeah, there's a big difference and there's not, or vice versa, because there's so many other factors that have to be weighted in that. So we chose to do the sample t-test. It's independent, and we're comparing the mean of one population with the mean of the other. It is independent because the cases do not, they don't interfere with one another. So what one campus does is not necessarily reflect one another, or it doesn't have any impact on the other campus. So my samples are definitely independent of one another. But I'm comparing to see, is there a significance difference or not, based on what the means were up here on the top. So of course, first after you pick your test, you got to check for the assumptions, because if your assumptions are incorrect, then of course your data will be skewed. So once again, of course, the random, I did not select these students, and I did not go look at specific campuses and try to figure out who did better than some other. I truly just selected 101 and 107 because you did, but knowing I could go through any campuses and choose those campuses would be fine, because they're still random. I did not choose those kids to come necessarily to my campus. So if I'm pulling samples, you just always got to make sure they're random, because if not, your numbers are always going to be skewed. Independence of observations, once again, I kind of answered that already. That's just meaning that everything works independent of one another. It's not really a cause and effect situation, or what this campus did is because of that campus, nothing like that. So that's why you do that. Now, 3 and 4, of course, are super important. First, we want to figure out, is it normally distributed? And if you look at mine from just a sample t-test previously, I felt like it was not normally distributed, even though we kept it that way. But by looking at these two, I can tell where these are normally are pretty close to normal distribution based on the way the graphs look, because you can kind of see how that curve, how it would curve just by looking at the bar graph. But if I want to get a little bit more in depth, then I can always look at the box whiskers or box plot graphs. But when I do look here, I can tell where these are very similar. And what I mean by that is this looks like more than 25%. You know, you want your 50 towards the middle and then 25 and 25 on each end. By looking at both of these, 101 and 107, I can tell that there's a little bit larger gap on the bottom half. Now this one's a little smaller, but I can tell a little bit gap here. But I still believe these are very close to normal distribution based on the bar graph as well. The homogeneity of variance means really that what you're pulling needs to be very similar. For instance, this is how I understood if it needs to be similar, because if I am only selecting a pool of 10 and then I have applicants of 1,000, 10 and 1,000 are two totally different. I'm going to get really crazy results because my pools are not close to being equal. So when I think about that variance, and you want it to be homogeneous, you want it to be very similar, almost the same amount on both sides, not necessarily the same grades, talking about mean, but you want it to be very similar, because if not, you're going to have, your data is going to be too skewed based on the numbers, like kind of your variables. So you want your variables of what you're actually running to be homogeneous. You want it to be very similar. And in this case, it was almost aligned, because you're going to see here 91 and 94. So really, that's pretty close compared to, say, 90 and 1,000. That would be such a big difference. So that's where I find that the checking for the assumption, it is. And, you know, I kind of feel like that's kind of logical. Like, you know, you're not going to check 2 people compared to 1,000 or even 100, really 2 to 100. I mean, that's a big number. And it kind of made me think about all the COVID going on, and just, you know, we look at the numbers and we think about all the deaths, but then when you really look at the rate of success, if you will, or the rate of, I can't even think what it's called, like the health of those not passing away, I mean, the numbers can just be skewed if you're not careful. So just make sure when we're selecting numbers, we really look at what you're pulling. And then, of course, we're just going to run the 2 tests. I'm thinking maybe my hypothesis should have come first. Maybe not. I could be wrong. But basically, it's just saying this will run for you. You just, once again, you pull the data. Of course, it's going to be using the data and the data analysis again. Now, for these charts, just a refresher in case I forget, the charts are found under charts, the histogram and the box and whiskers. But when I get to the F test, or the 2 simple variances, once again, that's the data analysis. And you're simply putting your data this time. How last time we used dummy data, we don't have to this time, because we actually have 2 different campuses. So our campus 1, we're going to select all the mean for it, and campus 2, you're going to select the mean for it to actually get your data. Now, of course, here's my observations. Here's what's my degree of variance. And as you'll notice, it's not just, it's -1 here. And that, once again, is just to give you just a tiny leadway. I mean, 1 is not going to make or break you in this situation. That's what there is. Now, here are where some of the tells are, and you're looking at the numbers. And I'll kind of go into that a little bit more down here when we get comparing those. So the first thing we need to do is going to be, of course, listen to the hypothesis up here. Of course, is simply saying we're going to fail to reject the null if they are the same. So if the mean of each campus is not significantly different, if they're very similar, then we'll fail to reject the null. But vice versa, we will reject the null right here in the second case if they are not the same and there is a significant difference. So those are just simply your hypotheses. They're always going to be very similar and almost the same. You're either going to have, if they are equal, it's always going to be that middle set. You reject the null, correct? Fail to reject the null, excuse me. Fail to reject the null will always be if they're equal. If they're not equal, then you're going to reject it. So that really is going to be the same. Your hypotheses are going to be very similar based on what your question is only a difference. And in education, we always talk about the alpha is always the same. It's going to be 0.05. That looks like 0.05. Let me correct that. 0.05 is always going to be the alpha, giving you that little bit of leeway. And then simply we're going to calculate some of the statistics. Now, what we have here is just some of the numbers that we are going to need. And I'm just getting my T value, my T critical value. And this time the chart is a little bit different because I'm doing a little bit different data. So that's why the chart looks a little bit different. To start though, this is just simply saying 91 and 94, that is my variable. That's how many students there were. Degree of variance for each campus is listed here. Now, for this one, I'm going to choose my degree of variance again, but this time it's 183. So as you can see, this is 180 to 200, but 183 falls closer to 180. And as you can see, it's only 0.001 of a difference. So I stuck with the 1.973. And that's where I got that the T critical number to be able to continue running my data. When we get to the right here, the two test sample, of course, we have the mean and stuff already, but it actually will do all this for you. You just simply use the data analysis and input that data once again. And it's very similar to the previous module. I worked on it yesterday after being sick, but it's very similar. The only difference is you have two tests. You truly have two independent tests that are comparing this time. So it pulls your data for you. And then once again, you can kind of vary. There's your degree of variance and so on. Now, this one is a lot different though than yesterday. So right here is my two-tail, critical two-tail, 1.97. So here would be 1.97 positive. Here's negative 1.97 here. Now, something very eye-opening or a little amazing. I don't know if it's obviously not good because it's such a big difference. It's negative 49. Well, we know negative 49 will be it would actually be off this page and on down my hallway, but negative 49 would be way down here. So we automatically know it's going to be rejecting the null. That these tests are those means are significantly different is really what this is saying. Due to this number being such a large difference, because we would want it to be right here. So it would need to be in between 1.97 positive and negative 1.97. Unfortunately, it's negative 49. So it's way, 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 way down the graph. So when I go to interpret the data, that's exactly what I'm going to find out, that they are statistically different. The means are very different. And so I'm going to reject the null. So here was interpreting that data. Here it was again. I failed to reject it if they were equal. I rejected if they're different. Obviously, I'm not in the middle section, so I'm on either the left or the right, meaning that they are not different, or excuse me, that they are different. And so we're going to reject the null. So at this point, I'm going to reject it. And right here is just that equation showing you exactly why I'm rejecting it. Because out of the 183, it just kind of breaks it down for you. And this was just showing you that mean. So the mean for the campus, one-on-one was 21.02. It was statistically different, obviously, than the other campus. But then, of course, if we want to go see the effects, just like last time, we can run all these extra tests. And in this case, since they are different, we probably would want to see really how big the effect size is and if there's something we need to do. If I was a principal on campus or analyzing data, we would want to do something because this would not be okay. And so this just kind of breaks it down for us and shows me, what kind of effect size am I talking about. So when I get to Cohen's D, here is that formula once again, the M1, which is mean for the first group, mean for the second group. And then we're gonna go into it. Now you gotta have the square root, the square root of the pooled variance. And that pooled variance is gonna be right up here. It's already there for you. So there was the number. And then of course you can just do it either with a calculator or you can actually do the pooled variance on Excel. So either way, but you'll get 6.74. And then after that, this is just where I typed in the formula right here for it and got that answer of the 0.488 by using this formula, and I just highlighted it here. So what this tells me that there is, as you can see, a medium effect. It's almost to the, I'm right at almost 50, a little bit more then we're going to have a large effect. So there is an issue here, you know, when you would want to do some more research and figure out what is going on. Because you can see that the means were statistically different. So you would want to say, hey, what's going on this campus? Hey, what's going on this campus? You know, what's going on, and figure out what the issue is to improve and make that number a lot smaller. Since there was a small difference, really, I guess it would be medium in this case. I'm going to fix that for us. Instead of being small, it's really medium. However, on the last test, we said it's felt to be a directed we would not be calculated. However, I would question, since I do have a large effect size, I would really want to calculate this now from my understanding, because I do have a pretty large effect size. So I would think I would want to do all this just to kind of make sure, am I on the right track, and kind of see where we are. But of course, this just does it shows me what that variable outcome will be. So, and of course, I have all these numbers again up top, up right up here, that -24. And then, of course, I'm going to square it, and then my degrees of freedom, and then I just simply put it in the formula to get my answer. And then lastly, you're going to need your confidence interval. Now, for this one, it is a little bit different because you're doing between the population, so your formula is a little different. And so you'll see down here towards the bottom for both of these, is really where I did all kinds of math here, just showing you really how I got it. But basically, if you have a TI-83 calculator, like I said, you can really type this in. And even Excel will do it all for you. You just have to make sure you put your parentheses where they go. But the problem is you don't have the numbers right off the bat. Like, you do not have this SM in 1 and 2, I believe it was, right off the bat. So you have to go put some data in to figure that out. To get the confidence. Remember, the confidence is really just seeing, I feel like, how confidence in the populations is it? Is it matching your original graph that you did up here? Or is it a lot different, to let you know how your data was? And is your data skewed, or is it along correctly? So here just kind of shows you, like I said, here's the means again, critical value. Now here's the number that I had to do all kinds of work to figure it out, the M1, M2 number, but this is to find it, but you have to do use these numbers and in this formula to get this number. And like I said, I did that all down here and just kind of broke it down so you could see the pooled variance, and then you might N1, N2, the number of cases, group 1, group 2, and then you got to do a little work with that, and square root you'll see is up there. So you can do all of it. It just takes a moment. I put that in there just for a refresher to me of how I got the answers behind it. So for future reference, I would know exactly what I did. But I do understand how to get the formulas and how to type them in a calculator. Just Excel, making sure those parentheses, so it's safer just to do it step by step. Unless you have a TI-83, you can check your work right then. But there is a calculator you can pull up on the internet as well that will type this for you. Oh, worst case scenario, you can do it step by step like you showed in the video, and like I showed you here, showed myself here, and still get the same answer. So once you get that number right here, which is the one that's a little bit tricky to get, to find that standard error of the mean, these other numbers you already have. So then you're just simply putting them in the formula. Here's your formula. You're going to have 2 because one you're going to add on. The other one's going to be exactly the same, but you subtract. Now, what this does, it does give me that confidence interval of -1.33 to -5.24. Now, I know this is on the far left, and if you remember up here on my graph, remember I was -49 way down here in the negative. So I know I'm on the right track, and I know it's way negative, and really just simply saying those means are statistically very different from one another. And, you know, I'm sure we can get more different, but that's pretty extreme compared to our sample t-test we did yesterday. And in this last module that showed that they were not very different. So this is just, once again, showing you that, you know, data can be tricky without running tests and running these different data analysis on it to figure out. So finding out the question is the most important. What question do you have, and how can we improve from there? So understanding that it was significantly different and that my effect size was so great, changes would need to be made. So hopefully this will help me in the future as especially I would love, I'm going to go ahead and get my superintendent, and I love data too. Just narrowing it down and figuring out, why do campuses do better than others? Is it true? Are they really doing better or not? Or is it just the way the numbers look? And then what can we do overall to increase the scores and close those gaps? So I learned a lot once again. This one was a lot easier, I found, I guess, because I had went through the other one so slow, really trying to understand what everything was. And now I'm not perfect. There's still some things that I get questioned or get stuck on. But overall, I feel like I have a much better grasp of all the different steps, why we do each step. But like I said, this one I kind of got tricked on because it shows we wouldn't calculate it if there wasn't an effect, but in this case there was a big effect. So I guess kind of where would we go from that route? But anyways, I look forward to the next module. I know that knowledge there's so much out there, the plethora of it, and I just look forward to continue growing and learning more about these t-tests and how beneficial they can be for me in my future. So thank you.